Well, hello there. This is Dr. Dell again, and we're talking about the triangle where you know three sides, A, B, and C, and you want to calculate its area. And as you've learned on previous videos in this interlude, I like to use the trig formula, the generalized Pythagorean theorem. And in the last video, I derived for you, however, two other formulas that did not involve trigonometry by using the Pythagorean theorem and quadratic equations, two of them, which we then had to solve. Not very difficult to do, and something I certainly would encourage my upper tier students to do just by way of good exercise and learning something. Although I must say I ended up with a formula that I didn't consider particularly attractive or useful, even though it works. Now, uh, there's another way to do this that I learned from Dr. Simmons' book, and it involves something that is called Heron's formula. Quite frankly, I had not seen that before until I read Dr. Simmons' book, and this was long after I had my PhD. I was teaching advanced mathematics out of another Dr. Simmons book on topology and functional analysis, and then I came across his pre-calculus book, and I was reading it, and I was kind of surprised to learn this formula. It was kind of neat. And here then is, let me show you what Heron's formula is. And this works for any triangle, so in particular we'll take the one with has sides A, B, and C. What you do is you define the semi-perimeter to be 1/2 the perimeter. Now the perimeter we know would be A plus B plus C. We certainly learned that in the foundation course. Anybody would know that if you knew anything at all about triangles. And the semi-perimeter is 1/2 of that. Well, then here's a formula for the area that works. You take the semi-perimeter S, you multiply times S minus A times S minus B times S minus C, and those four terms multiply together, take the square root, and bingo, there's the area. Wow. That was neat. I saw that in Dr. Simmons' book. It was on page 18. I'm going to put that book under the camera now. And if you go to page 18, as a matter of fact, he gave it as a problem in the problem set on geometry, number 20. And not only did he give us the formula, but he actually gave us then a set of steps to derive that formula. And I must say these are very clever. I doubt if I ever would have figured them out for myself. Hindsight's always 20/20. Once you know something, sometimes you can work backwards and figure out a clever proof of it. And I think that's kind of what he's done here. You follow his steps and you certainly get the thing proven. And then in problem 21, he does the same thing where he draws the triangle that I'm actually using in a slightly different format, because this works for both any kind of a triangle. I must say I did not find this proof very enlightening. It works and I can follow the steps, but where did he come up with it? How did he figure out how to do that? That is really kind of the question. Now, you might study that and find it more intuitive and reasonable than I did, but that's what he did, and so this could be used then to find the area. Maybe that's what Wolfram Alpha did. Now, what I did, though, just to be sure that it was equal my formula, which obviously it has to since they're both accurate, I took this number here and I multiplied it all out and verified that it equaled this number right here, which, as you may recall, was the first thing that I had come up with in my original derivation, which involves this term here, minus a to the fourth, minus b to the fourth, minus c to the fourth. And that's what this turns out to equal very easily. It's a little messy, but it's easy. And so you could take the definition of S, and then you can just multiply out what's inside here. Forget the square root sign, what's inside, and that'll equal that. And then so that shows that if you take this, that's equal this divided by 4, and it's a little messy. So now the question really is, where did Heron come up with this formula? Or for that matter, where did Dr. Simmons come up with it? That's a good question. I don't know the answer. I don't know the history of it. It works, and it can be proven. Dr. Simmons gives a proof of it, and of course, I've given a proof of it now. Of course, I wouldn't have known to do it unless someone had told me this formula to start with. So that's kind of a mystery. It's a historical mystery. And maybe this is the formula that Wolfram Alpha used, was this Heron formula. Now, as a matter of fact, there's another formula that Dr. Simmons gives that's really, really clever and leads to some really interesting mathematics that I'm going to tell you about on the next video, and it may very well shed light on where Heron found his formula. But I'll warn you in advance that it involves some trigonometry. But it's a very, very interesting formula that's in Dr. Simmons' book that every high school math teacher ought to know about, and certainly offer it to their better students, the ones that are really up into the tier 3 and tier 4 level. So this is Dr. Dell signing off. There'll be at least one more video coming in this interlude on this other formula that I'll tell you about. Bye-bye.